Hello scholars and welcome. Mr. Hinkle here. Today we're going to introduce the concept of what is a map. Now maps can be anything, but there is a standard as to what maps are today, and maps are a two-dimensional representation of a three-dimensional surface. That three-dimensional surface being our planet Earth. So we're trying to portray our planet in a way that we can look at on a piece of paper so that we can go out and we can explore and we can know what is out and around us based on the work that others have done before us, so we can not get lost, so we can put information on them, so we can understand large areas in small amounts of info. So, a map is a flat representation of Earth's surface, and maps have some key pieces to them. A map has a title. What's the name of this map? Half Dome Quadrangle, Road Map of Fresno, so on and so forth. A map has a scale that helps you to know what the distances are that you're looking at. A map has a legend. A legend is going to tell you what all the symbols and everything else that you might not understand actually mean. A map has a compass rose showing you which direction is north and what the directions are. The cardinal direction is never changing. We'll talk about that. And then a map has a grid, a coordinate system that you can find yourself on that map. So let's go through some of the basic types of maps. World maps. They can depict anything: weather, geology, plate boundaries, volcanoes. They can focus in on countries. You can zoom into cities. You can have the entire world. Pretty much any map that looks at our Earth. Road maps. These were really popular before the smartphone came around. Smartphone came around and all of a sudden everyone's reading maps, or at least the maps are reading to them. When I got my car, way back when, I'm not that old, but I started driving in, 2003. And smartphones weren't a thing yet. I wanted to go places. I wanted to travel. And so in the back seat, I had these really fuzzy seat covers, and my Nissan, it was a 94 Nissan Sentra, 5-speed, super fun little car. Loved that thing. Took me everywhere I wanted to go. But there was these back pockets behind the seat covers, and I had all the maps. Map of California, map of the world, map of San Francisco, map of Santa Cruz, maps of anywhere I wanted to go. And literally be like, okay, where do I want to go? I'd open up the map. Or the internet was pretty popular then, just coming around. And we'd MapQuest it. So you'd put directions into MapQuest. But inevitably, well, MapQuest was this feature. It was a website that you type in your destination and it'd give you directions, and then you'd print them off and you'd take those directions with you with a little map. But inevitably, you'd miss a turn and get lost, and if you didn't have the actual road map, you were lost. So, fun times with maps. Topographic and geologic maps, these are going to be what we get into more detail in another lecture, but topographic maps are showing elevation, water features, and are really giving us an idea of the relief, the slope, the elevation of our Earth's surface. And geologic maps show the geology. Pretty cool. We have a round Earth. It's a sphere. Maps are two-dimensional, usually squares. And to take a round Earth and put it on round Earth and put it on a two-dimensional map, well, that means that the top of the map is a really tiny little bit of area. So it has to get projected. We'll do the equator. Something like this. It has to get projected. And there's lots of various projections, but the most common one is the Mercator projection, of which we can apply latitude and longitude. You might have heard of these things, but they are a coordinate system. Now, when we want to orient ourselves on a map and know what way is what and where we're going, we have this standard method of directions. It's called the 4 cardinal directions, where up is north, down is south, to the right is east, and to the left is west. And we apply these cardinal directions to our Earth, giving us the North Pole and the South Pole, meaning we could travel east, we could travel west. And the cardinal directions are important because it helps us to standardize what direction the sun comes up in. The Earth spins from west to east, and we see the sun rise in the east and the sun set in the west. So directions are relative to the 4 cardinal directions that allow us to orient ourselves both on a map and on Earth. So direction, wildly important, one of my favorite things. Love direction. A coordinate system is important to locate yourself on a map. How do we know where to go? This big old Earth. Well, there can be a grid that's overlaid. That's what all of these lines are. The ones that go up and down, the ones that go left and right. So a grid system is important. There's lots of grid systems. The one that we're probably most familiar with is latitude and longitude. Latitude is going to be your location north or south of the equator. And longitude is going to be your location east or west of the prime meridian. Prime meridian is an imaginary reference point. We call it 0 degrees. Now, these are both calculations. It's the distance between where you are relative to the center of the Earth relative to the equator for latitude, and then it's where you are through the center of the Earth relative to the prime meridian for longitude. So we have these 2 different measurements that are using properties of the Earth, the angles between where you are to the center of the Earth and either the prime meridian or the equator, to give us our latitude and our longitude. Now, the last important thing that you need on a map is to know, what is the scale? What is the scale? So does that mean that 1 inch equals 1 mile? Does it equal 100 miles? Does it equal 1,000 miles? Because this is going to change the way that you view the map. Does 1 inch equal 100 feet? If you're looking at a map and 1 inch equals 100 feet and you're 1 inch away from your destination, you could say, hey, let's walk there. It's 100 feet. If it's 1 inch equals 1,000 miles, you might need to plan a multi-day car trip to get there, because that's pretty far. So understanding the scale is wildly important for understanding the information on the map, the geographic distribution, the spatial distribution on that map. So here's a map of the world with the Mercator projection that has the latitude and longitude grid system overlaid. Now we want to figure out where we are. Let's practice. Point B. Okay, here's the equator, 0 degrees. Here's the prime meridian, 0 degrees. This direction is west, this direction is east, this direction is north, and this direction is south. So if we go from the prime meridian, we're going to go to 40. That's 80. In between, likely 60. 60 degrees west. And if we go from the equator, it's 20, 40, 50 degrees north. So for our practice, let me erase some of this. If we are looking at point B, we could say that point B is 60 degrees west and 20, 40, 50 degrees north. Awesome. Let's do one more, and then I'll let you practice. How about H? So we're going to go 40, 80, 120. That would be 140, but it looks like it might, if we did a line down from H, I'd say that's about 150. So we could say that H is around 150 degrees east, because it's east of the prime meridian. And then H, right? So here's 0, 20. And if that's 40, halfway between is 30. So that might be just 25 degrees south of the equator. So let's call that 25 degrees south. Could go the other way. You could tell me what is that 20 degrees south and 42 degrees east. 20 degrees south, 42, let's say 45 degrees east. Madagascar. Cool. So maps are awesome. They convey information. They're graphical representations of our Earth. They're 2D representations of a three-dimensional world. There's pieces to graphs that we need: a coordinate system, a direction system, a scale. And when we have those things, we can understand how to read a map to decipher the information that they are presenting so that we know where we are, what we're doing, how we're getting around, and any other information that the map creator wants to share with us. Thank you so much. That's a brief introduction to maps. Hope you enjoy it. Let's go read some maps.